Welcome to the TWIML AI podcast. I'm your host, Sam Charrington. Hey, what's up everyone? We are just 1 week away from kicking off TWIML Fest, and I am super excited to share a rundown of what we've got in store for week 1. On deck are the Codenames Bot Competition Kickoff, an Accessibility and Computer Vision panel, the first of our Wellness Wednesdays sessions featuring meditation and yoga, as well as the first block of our unconference sessions proposed and delivered by folks like you. The leaderboard currently includes sessions on sampling versus profiling for data logging, deep learning for time series in industry, and machine learning for sustainable agriculture. You can check out and vote on the current proposals or submit your own by visiting twimlai.com/TWIMLfest/vote. And of course, we'll have a couple of amazing keynote interviews for you, which we'll be unveiling shortly. Registration and all the action takes place at twimlfest.com. So if you have not registered yet, be sure to jump over and do it now. We'll wait here for you. Before we jump into the interview, I'd like to take a moment to thank Microsoft for their support of the show and their sponsorship of this series of episodes highlighting just a few of the fundamental innovations behind Azure Cognitive Services. Cognitive Services is a portfolio of domain-specific capabilities that brings AI within the reach of every developer without requiring machine learning expertise. All it takes is an API call to embed the ability to see, hear, speak, search, understand, and accelerate decision-making into your apps. Visit aka.ms/cognitive to learn how customers like Volkswagen, Uber, and the BBC have used Azure Cognitive Services to embed services like real-time translation, facial recognition, and natural language understanding to create robust and intelligent user experiences in their apps. While you're there, you can take advantage of the $200 credit to start building your own intelligent applications when you open an Azure free account. That link again is aka.ms/cognitive. And now, on to the show. All right, everyone, I am here with Adina Trufinescu. Adina is a principal program manager at Microsoft working on computer vision. Adina, welcome to the TWIML AI podcast.
Thank you so much for having me here.
Absolutely. I'm really looking forward to digging into our chat. We'll be spending quite a bit of time talking about some of the interesting computer vision stuff you're working on, in particular, the spatial analysis product that you work on and some of the technical innovation that went into making that happen. But before we do that, I'd love for you to share a little bit about your background and how you came to work in computer vision.
Definitely. I have joined Microsoft in 1998, so I'm a veteran here, and I started as an engineer. So I have an engineer background, not a research background. And then after spending more than 10 years as an engineer working on primarily Windows OS, I switched for program management, and I worked on a bunch of products until eventually I started working in Windows on speech recognition. At the time, I was working on Cortana speech recognition. And then later on, I worked on speech recognition for HoloLens, the mixed reality device. And then for the past year and a half, I transitioned to computer vision. So I'm a program manager. I'm working with both the engineering and the research teams on shipping spatial analysis. And then spatial analysis, it's a feature of the computer vision service in Azure Cognitive Services. And then it just shipped as of this week at Ignite in public preview.
Nice. And any other year, I'd ask you, what's it like down in Orlando? Because that's where Ignite is historically held. I've been to the last several and have done podcasts from Ignite, but this time we're doing it a little bit virtually as Microsoft is with the event. But super excited to bring to our audience a little bit of this update from Ignite. Tell us a little bit about the spatial analysis work that you're doing there, and start from the top. What's the problem that the spatial analysis is trying to solve?
So Before I talk about spatial analysis, let me give you a bit of background information about Azure Cognitive Services for computer vision, because it's important to highlight the difference and the novelty that spatial analysis brings. So the existing computer vision services are image-based, meaning that basically the developer passes in an image at a time, and then the inference happens either in the cloud or in a container at the edge. And then the result of the inference, image by image, is being sent back to the developer. Spatial analysis brings the innovation of actually running computer vision AI on video streams. So basically, it analyzes live. It can also do recorded, but primarily it was designed for live video streams and real-time analysis of these video streams. And in this case, for the purpose of understanding people movement in physical space. And then when you talk about people movement, we're talking primarily about four things. The first one is the more basic scenario of people counting. So basically in a video stream, we run people detection, and then either periodically or when the count of people changes, we provide the AI insight indicating how many people. And then we have social distancing, which is actually called people distance, but we call it social distancing for the obvious reason. But basically, you can configure the desired threshold at which you want to measure the distance between people. And then let's take the magic 6 feet number, right? So basically, the AI is going to detect the people in the video stream. And then every time when the people are closer than the minimal threshold, then an event is being generated, indicated that the minimal distance has not been respected. So these were the first two, and then the next two are what we call entry and exit of physical spaces. So to actually detect when people enter or leave a physical space, we have two operations. One is called person crossing a zone, in and out of a zone, and person crossing a line. So let's take the example of person crossing a line. Let's say that you have a doorway. So you can draw a directional line, and then every time the bounding box of the detected person is crossing and intersecting the line, then we can generate an event telling you that the person entered the space or exit the space.
Awesome. And so the context in which this is being offered is you mentioned the comparison to the image-based services. An image-based service might be something I'm using that to do object detection or segmentation of an image. I'm passing that to an API and I'm getting a result back where the service is telling me what it thinks is in the image and the probabilities. And this is extending that same general idea to video, essentially.
That's right. And then we started with the spatial analysis for people movement, and we're looking to extend this to other domains, for other relevant scenarios in the future.
Mm-hmm. And can you give us an example of the other types of scenarios that folks might want to perform on video?
So, there are many industries where this is relevant. So basically, you can think about retail, which currently is targeted towards this person movement analysis. But think about again, in the current events, let's talk about vehicle analysis. So that would be another kind of object that when detected in a video, then you can have interesting AI insights generated and interesting scenarios.
Mm-hmm. And so, from even that explanation, I get that unlike an image-based service where, generally these work along the lines of ImageNet, where you have these many classes of things that can be detected, toys and fruit and oranges and things like that. In video, you're starting with very specific classes. Can you talk a little bit about why that is? Is it use case driven and that counting people and vehicles and very specific things are more interesting in video than counting random objects? Or is it more a technical, issue or limitation?
It's not a limitation. So we started with understanding people movement because this is where the customer signal was. So I've mentioned retail. We also have many scenarios in manufacturing or in real estate management. And also the current events was also informing our decisions on when to start. But the way the video pipeline and the detection models are being inserted in the video pipeline is fairly generic, which is why we're looking at enabling other domains in the future. So basically, the detector model that we have for people today can easily swapped with a different detector model for a different domain.
Okay. And, in thinking about the use cases, it sounds like the use cases that you are envisioning are camera-based video streams as opposed to I'm going to pipe in a stream of commercial television and ask your service to find anytime a particular can of Coca-Cola shows up or something like that. That's another use case that I see every once in a while, but it's clearly it's not one you're going after at this point.
Not for now. And speaking about the cameras that we work with, these we don't actually provide like a given model. So any model that supports the RTSP protocol, which is like the universal protocol. Well, I shouldn't say universal, but it's a common protocol for video streaming. Mm-hmm. So you can have like a camera, or you can have like an NVR. Any video management system that actually is capable of streaming over the RTSP protocol. We work with that.
Okay. And NVR being network video recorder.
Yeah, that's right.
Common surveillance use case or technology used in that use case.
Yeah, that's right. So basically, we're looking not only at greenfield scenarios where customers install new cameras, but also at existing cameras and existing video systems.
Mm-hmm. And so when I think about this type of use case, it makes me think of something like a Ring camera where maybe I can grab a Raspberry Pi or something like that and, have it call out to this service, put in a little USB camera on my Raspberry Pi and, stick it by my door and kind of do a roll your own Ring camera and have it count people that go into some zone or something like that. Could I do that with this?
You can do something like that, but the device that we are supporting and we have tested extensively for is actually a more of a heavyweight device. It's an Azure Stack Edge. So what?
A lot heavier weight.
Exactly. Yeah. But the idea here is that what we have in mind is actually these like spaces where you have like up to. You can have like dozens of cameras, or you can have like hundreds of cameras. So imagine like a warehouse where you could potentially have like hundreds of cameras. And basically we wanted to have a way where you can deploy at scale and you can manage these cameras at scale. And then because video has this sensitivity around the privacy concerns and data control concerns, basically that's where Azure Stack Edge comes in, where you can actually keep the video on your premises and then all the processing happens on the Azure Stack Edge device. And then only the result of which is the de-identified data about the people movement can be sent to the cloud, to your own service in the cloud, to your own tenant, and then you can build a solution in the cloud. And then I should be more specific that the Azure Stack Edge device that we are running with is actually the one that has the NVIDIA T4 GPU. So even a more departure from a Jetson Nano. This is like the initial release. This is the public preview, and then we're looking at extending the range of devices and the hardware acceleration capabilities for something lower, something less than Azure Stack Edge.
Got it. And for folks that aren't familiar, Azure Stack Edge is essentially it's a pretty heavyweight hardware setup where you're essentially running the Azure cloud in your data center. That's the general idea, right?
Yeah, that's right. And, if you have like a small space where you have, let's say, 20, 50 cameras, you don't really need something of of the extent of a data center. You need like a room, a server room.
Closet or something like that.
Yeah, a server closet with a temperature, reasonable temperature where you can run these devices.
Okay. So I'm going to have to wait quite a while for this technology to be democratized, if we will, to the point where I'm running it on a Raspberry Pi with a USB camera.
I would hope it's not quite a while, but not yet.
Not yet. And I think in this day and age, I think we have to talk about surveillance and the role of technologies like this in enabling different types of surveillance use cases, some of which are problematic and some of which are kind of necessary in the course of doing business. What's the general take on making this kind of service available for those kinds of use cases?
So when we release spatial analysis, we had in mind what Microsoft calls responsible AI and innovation. So this is where we recognize the potential of harmful use cases, and then with this release, we also released a set of responsible AI guidelines, which had like 3 things in mind. The first one is protecting the privacy of the end user, providing transparency such that the end user and the customer understand the impact of the technology, and then in the end promoted trust. And then the idea there is that we want to pass these responsible AI guidance and practices to our developers and our the people that actually build the end-to-end solutions, such that the end users, the people actually impacted by the technology, can actually be protected, and then the human dignity of these people is actually upheld.
Mm-hmm. So it sounds like even if I did have an Azure Stack Edge, I couldn't necessarily just turn on this service and do whatever I want with it.
So we have a process from that we take our customers through, at least for this public preview, where you get access to the container. So I'm not sure if I mentioned this, but we started not with an Azure service in the cloud, but with a Docker container that you run on your premises on Azure Stack Edge. And basically the container, anybody can download it, but to actually access the functionality in the container, we want you to fill in this form. You describe the use cases that you are considering for actually your solution and your deployment. And then we will look together whether these use cases align with the responsible AI guidance. And then if they do, obviously you can proceed. And then if they don't, we will have that conversation to make sure that the responsible AI guidance is upheld.
Okay. Well, let's maybe shift gears and talk a little bit about some of the tech that, went into enabling this. In order to do what you're doing, some kind of standard things like object detection and, is that this like fresh out of research papers, new techniques to do the detection and classification, or how did what are some of the things that you're doing there and the challenges that you ran into in productizing this?
So I think the challenges, they vary depending of the 4 use cases. So let me try to break it down and then address each one. So for instance, we are running a DNN for people detection. And then we started with something like more heavyweight, and then we had to transition because of the performance concerns. And I'm going to come back to that in a second. But basically, we had to transition to a lighter model. And then
a big ResNet and...
So let's say like a big ResNet to a smaller ResNet.
Okay.
I'm going to leave it at that.
Okay.
But the idea there is that, for instance, for something like people counting, initially for all operations, we started thinking that we can stream at 15 frames per second. And then we did that. And then we've noticed that, to get maximum usage out of that Azure Stack Edge, which is like quite heavyweight, right? You want to run as many video streams as possible. So basically, we try to actually go as low as possible in terms of frame rate. And then for something as person count, the person count, from 1 second to another doesn't change dramatically. So for something like person count or person distance, we actually went from 15 frames per second to 1 frame per second. And then we were able to actually maximize the usage of the GPU, because now the DNN runs at a lower frame rate, and this way you can fit in more video streams. The challenge we had, for instance, with social distance, with person count, was actually around of generating ground truth. So annotate like a 10-minute video where not only, and let's say you have in the video and you have to annotate the distance between these people. Just looking at the video, you cannot figure out like the physical distance between people. So that is where we use synthetics video data. So basically, we are using the same technology that our colleague teams in mixed reality for HoloLens are using, where we generate these game scenes where we can actually control the positioning of the people and then their relative positioning, and then we were able to generate this ground truth data such that we can actually the robustness and the accuracy of algorithms tested and then brought to a level where we were satisfied with it. So that was the first challenge for person distancing. The second challenge is that the DNN is going to tell you whether there are people in a frame, but it's not going to tell you like the actual physical distance. So for that, you need the camera to really be calibrated. So this is where, initially, the initial thinking was that we will ask the customer for the camera height, for the angle, for the focus distance, but that wasn't practical either. So this is where we had to actually come up with a calibration algorithm for the camera, such that before the actual operations where the DNN runs, for the purpose of the operation, the algorithm for calibration kicks in, such that we ask the customer to have like at least 2 people in the camera field of view, and then the algorithm runs for detecting these people and makes assumptions for their positioning, and this way the camera height and the focal distance are actually calculated, and then we pass it back to the customer as output and we want to make sure that actually that reflects the reality. But between like ground truth and the camera calibration, these were the 2 challenges for person detection.
All right, so just maybe taking a step back, we started out talking about counting people, and it sounds like there's some research or work that went into getting from kind of this big heavyweight model to the smaller model. And so that was one element of it, but also just fine tuning the end-to-end process in terms of how quickly you're able to do it. In other words, what the frame rate you're using for counting people. That was part of counting people?
Yeah, that's right.
It was this kind of just an iterative process, keep reducing the frame rate until things start breaking and you're not able to count accurately, or was that something where you're building out models to tell you how low you can go or something? What all went into that?
So it was a little bit of both. It was like a constant measurement of performance and accuracy, where, in terms of frame rate, we would go like lower and lower to the point where we can maintain the accuracy and precision rates. And then, you reach your breaking point, and then that's how that you have to stop. And then when you have to stop, that's I wouldn't say that this was exactly how it happened, but there is the constant. When you talk about like frame rate and doing all these tests, this is where the engineering comes in, and then when you come like about the performance of the DNN and the models, this is where research teams are making progress in parallel. So basically, it was like an iterative process where between engineering and research, they both work together to arrive to what seems to be like the best balance between performance and accuracy.
Mm-hmm. And as part of that counting people process, you've got 2 sub-problems there. One is identifying the people in the frame, and then you also kind of have to know from one frame to the next which person is which. Is that a part of the challenge here?
Yeah, that's right. So especially for person crossing in and out of a zone and person crossing the line, that's where the tracking part of the algorithm comes in. And basically, to be able to tell that the same person is the same person from like one frame to another, in addition to the DNN model, we are running a combinatorial algorithm such that detection is telling you that I have these people. And then by extracting features, we can actually run the combinatorial algorithm to tell that, from frame T-1 to frame T, we have the same set of people. And then basically, as people are detecting across the frames, they are getting this anonymous identifier, which tells you that, there is the same person from frame 1 to frame 10, something like that.
Mm-hmm. And you mentioned extracting features to help the combinatorial algorithm. Are you kind of pulling those out of kind of the bowels of the DNN, or is this a separate pipeline or a separate flow that is identifying features in a kind of more traditional computer vision way?
So we actually pull it from the DNN, and we have the typical feature that you would expect, like motion vector, velocity, and direction in the 2D space. And basically, frame by frame, we are looking at all these attributes, and then we're making the decision whether the same person is, the same person shows up across the various frames. And then I should say that each person gets an identifier, and that is an anonymized identifier. Basically, there is no facial recognition or anything of the sort.
Okay.
And then I should actually say that, in our pursuit of performance, we started this process at running at 15 frames per second, because in case of when you're actually looking closely of how people move in and out of a zone or cross a line, the action of crossing and the time the person crosses that line is fairly short. So we had to run at more than 15 frames per second. So this is where we initially started, by running the DNN for the people detection every 15th frame, still keeping it at 1 frame per second, and running the association algorithm every frame. The problem that we had was the accuracy and the performance, had all the typical challenges where the identity of the people will be switched, or the identity of two people will be merged. This is the fragmentation and merging, typical challenges with association. So if you don't actually run the detection on each frame, every time when a person is occluded, or every time when a person disappears from the frame, or a new person appears, that's when you have all these association problems of merging and fragmentation. So that was another motivation for us to go to a lighter DNN for person detection, something that we can actually run each frame at 15 frames per second.
Okay. But you mentioned that there are some parts of the problem that you do down at 1 frame per second?
Right. So just to recap, person counting and social distancing, we do it we keep doing it at 1 frames per second, and then person crossing a line and person crossing in and out of a zone, we run at 15 frames per second.
Got it. And the main idea there is that for counting people and counting distance, it's not an associative problem. You're just looking at what's in the frame, and it doesn't matter if someone bounces in or out, between frames. If they're not in the frame, you don't count them. But when you're talking about entering and exiting physical spaces, you want to keep track of who was already in the space versus who wasn't in the space in order for you to provide an accurate count. And so you have to, there's a bit more accounting that has to happen. And then you get these challenges with people, disappearing because they, were at the edge or something like that. And that's where you have to focus on these segmentation and merging problems.
Yeah, that's right. So imagine that counting people or social distance, not a lot whole happens in a second, but when you have a doorway, so imagine that you have a railway station and you have a doorway where a dozen of people needs to pass through. At that point, you have to run people detection a higher frame rate, such that you do not lose the people. Mm-hmm. Or do not, or people, you do not lose them when they show up, and you want to lose them when they disappear.
Yeah. And so you mentioned a bit about the training data challenge that you ran into there. And this is related to that last problem we talked about with entering and exiting physical spaces. Is that correct? Or is it?
Yeah, that's right. Right. So this is where ground truth was also challenging in terms of take videos, and these videos can be 10 minutes to 1 hour. And you could have depending on like which space are you using, you could have like few people, or you could have a dozen, or you could have like 100 people, right? So annotating that data frame by frame at 15 frames per second, that's a lot of work. And not only that, you have to track that the same person from this frame across all the 15 frames times this many minutes is the same person. So that is like an impossible, I mean, it's possible, but you don't want to do that. You don't want to ask any human to do that. So this is where...
if I can just jump in, if the network isn't tracking the people, but it's a combinatorial type of algorithm, is that a non-learned algorithm where you don't need to train on associating people, or do you also need that?
Yeah, so that is not a DNN. Actually, it's an algorithm, and you don't have to train it. So what we are training is the people detection model, and then the testing is actually so basically we are testing independently first the people detection model, and then we are testing the tracking aspect of it, and then we are testing the combinatorial algorithm. So that's where the ground truth needs to cover all the use cases, but then the most challenging one is the one where you have to generate ground truth that actually annotates each person and the identity, the anonymized identity of each person across the frames.
Okay. Yeah, I was trying to make sure that you actually had to track that, because that would seem to make the data collection process quite a bit more challenging when you're annotating the identity of folks. That can be, if we're talking about images that look like a overhead image of Grand Central Station or something, I would imagine that to be difficult for a human annotator.
It's model. Right. So basically, this is where synthetics plays on the same role as before. Basically, we are generating all these synthetics videos where not only that, we want to make sure that is the same person across the video, but you want to make sure that the pathing of the people in physical spaces across the use cases is most realistic. And then you want to annotate that. You have the different camera angles, you have the different the heights, and you have the lighting conditions. So basically trying to go into the real world to collect all that data and then to annotate that data, that would be a real challenge. So this is where synthetics played like a huge role and was like a huge time saver.
Mm-hmm. And where does this synthetic data come from? Are we talking about, did you take an Xbox game that kind of looked like it had people in a crowd and try to use that? Or did you develop a custom data generator for this problem?
It's pretty much like it's the same like I said, it's the same technology that is being used for HoloLens and for mixed reality. The same kind of the technology that powers the scene generation. Basically, we didn't take a game, but the concept is like very much game-like, where you can overlay like an image of actual physical space, and then you can start like placing all these characters into the 3D space, and then generating the video streams out of that. And then because you can play with the physics and then with the lighting, you can have like a great variation. And that is actually what we need to assure the high quality of the AI models and of the combinatorial algorithm.
Mm-hmm. And is that synthetic data approach also related to the camera placement approach that you mentioned? Are you varying the camera angle as part of the synthetic generation?
Yeah, that's right. So basically, the goal was that the AI models, so computer vision has custom vision, and we want people to go and create, custom vision models. But to the extent where they don't have to, and then we can actually save them time by creating these high quality models, which perform great in all of these conditions, we want to do that. So the goal there was that when we train and when we test with data from all these like various conditions. So part of the synthetic data was to actually, like the ceiling in a retail space is different than a ceiling in a manufacturing space. So this is where you need to bring in that variation.
Okay. And from a customer perspective, are they, sending you pictures from their camera and there's a model that kind of figures out where their camera might be, or you mentioned that you don't want them to have to, send you measurements or anything like that. What's the input to that process?
So basically, we do not collect data from customers, and basically any in the product, none of the video that is being processed is actually used for training. So the way we are approaching this is actually visiting customers, looking and learning about their environment, and basically learning about the parameters of the environment, such that we can simulate it. And then we also create simulations of the real world scenarios. Obviously, not manufacturing, but imagine something like a store layout. That's something that you can actually emulate fairly easily. And then basically in that scenario, you have something where the camera is at 10 feet or camera is at 20 feet, and then you're looking at like the different angles and the different areas in the store where you want to actually apply the person crossing zone, person crossing line, and that's how you actually generate the synthetics data.
Got it. Okay. And then finally, you started to mention kind of measurement and some of the challenges that measurement posed for this problem. Can you elaborate on the way you scored these models and how you assess their accuracy?
So we applied the MOTA challenge, and then we used the data set to actually track the accuracy of the person detection and the person tracking model. So we applied the MOTA, the MOT accuracy and precision formulas, and then we score.
Challenge is multi-object challenge benchmark.
Multi-object tracking challenge. So basically, we apply like the industry standards to assess the precision and accuracy of the model. But the thing that we did a bit different was that the actual output that goes to the customer is not actually, frame by frame, the result of the detection or the tracking. What we actually send to the customer is the count of people, the distance between people, the time they spent in a zone, or the entry and exit events in the zone, such that they can calculate the dwell time. So basically, we looked at the use cases and we came up with accuracy measures specific to the scenario. And then we generated ground truth such that we can test holistically not only the tracking part of the algorithm, but the end-to-end algorithm between tracking, association, and applying this logic of like person crossing in and out the zone or person crossing in and out the line.
And so did you extend the challenge benchmark to your specific use cases and the higher level metrics that you're providing to customers, or did you have a separate parallel path that was more reflective of your specific kind of use case specific numbers?
It's pretty much specific to the use case. So to give you an example, for the person entering and exiting a zone, we looked at what we call dwell time, which is a fairly common use case for what people want to measure. And then we looked at the timestamps for the ground truth. We created ground truth by looking at the timestamps of real timestamps of like people entering and exiting the zone. And then we actually created like measures for that particular, the dwell time or the person entering or the person exiting. It's pretty specific to the scenario, but it helped us to assure that the actual accuracy of the end product, which is what the customer is actually consuming, is at the level that, is satisfying the customer requirement.
Mm-hmm. And with these measurements in mind, did you give up a lot going from kind of the huge, DNNs to more compact DNNs and changing frame rates and things like that? All these things that you needed to do to deliver a product that worked in kind of the environment that you were looking to do. Did you lose a lot in accuracy for the measurements that you're trying to provide?
Not really. Actually, the goal is to gain in accuracy. So we will not. Basically, you have to make trade-offs, and then you have to balance, and it's always like a tug of war between accuracy and performance. But basically, working with customers, and then, that's why we have this public preview, and before the public preview, we had the private preview. So basically, we work closely with a set of customers to actually validate the accuracy of the end-to-end algorithm for their use cases. And, there were some learnings that we took away, and then that's how we arrived by making the right trade-offs such that both the accuracy and the performance and the cost of the end-to-end solutions makes sense.
Awesome. And you presented on this at Ignite this week when you kind of unveiled the public stage of release. Any takeaways from your presentation or the reception to it?
So it was well received. I would say that you stay so much focused on performance and accuracy, and then the feedback that we got was, and it was like very strong feedback. For instance, the measure between people we provided only in feet, and obviously, that's not. You have to stay focused on everything that matters, and then you shouldn't it wasn't like we tried to move fast and everything happened like so fast. And then, this is something that we planned during the pandemic months. And then, the 6 feet that you hear every day stuck with us. And then we realized that, our customers need, the metric system. So we had like feedback like that. But then at this point, we are very excited to have the customers try it. And I'm pretty sure that there will be more learnings.
Awesome. Well, we'll be sure to link out to the service where folks can find it in the show notes. But thanks so much for taking the time to share with us an update on this new service and what you're up to.
Yeah, it was my pleasure. Thank you for having me.
Thanks, Adina. All right, everyone, that's our show for today. To learn more about today's guest or the topics mentioned in this interview, visit TWIMLAI.com. Of course, if you like what you hear on the podcast, please subscribe, rate, and review the show on your favorite podcatcher. Thanks so much for listening, and catch you next time.